All right, here we're looking at section 2.1, and our essential question for this section is how do the constants a, h, and k affect the graph of the quadratic function g of x equals a times the quantity x minus h squared plus k. So remember that when we're talking these different functions, I'm going to start with my parent function. And my parent function here is just a quadratic, so it would be kind of f of x equals x squared. Right? This is the most simple form I can get. And then I'm going to add these different values in and see what happens to it. So my learning targets for today, first we're going to describe transformations of quadratic functions, then we're going to write those transformations of quadratic functions. Okay, so the first ones we want to look at are our translations, both horizontal and vertical. So with horizontal, you'll notice that it's inside the parentheses. Okay, and I'm always going to have x minus h. It's always going to be x minus h. So when h is greater than 0, right, so I've got like an x minus 4, it shifts it to the right, and if I've got an h value that is less than 0, it's going to go to the left. And we'll look at some examples of these. So now our vertical translations. Vertical translations are always going to be k, and you'll notice here that k is not inside my parentheses. So if k is greater than 0, it moves up, and if k is less than 0, it moves down. Right? So our k value, our vertical translations, are generally easier to see and understand than our horizontal translations. But let's look at a couple of examples of these, and then we'll see what we can see. So describe the transformations of f of x equals x squared. So here's our parent function. And then we're going to do the transformations to get us to x plus 4 squared minus 1, and then graph each function. Okay, so the first thing I notice is that honestly, the things that I've changed, right, is I have a value here, and I have a value here. And I'm going to use different colors. Well, I know that I always have to write this as x minus something squared, right? Always x minus. Well, so I want to take this and turn it into a minus. So it's going to be x minus a negative 4 squared. And then this is going to be a negative 1, right? So this will be plus a negative 1. So this kind of tells me the values that I'm using. So I see inside my parentheses, I have a negative 4, so I know I'm going to be shifting my graph to the left 4 units. This 1 out here is a negative 1, so it tells me I'm going to be shifting my graph down 1 unit. So now let's look at what we've come up with. Okay, so here's exactly what we did. We just rewrote this, so I have x minus h, and then plus k. So now I can see my h and k values, so I shift my entire graph to the left 4, and down 1. And this is what my new graph looks like. I don't have any stretching or shrinking yet. I just have shifted the entire graph. So here are a couple to try. First, see if you can identify your h and k. That's always going to be our first step, is finding our h and k, because that tells us where we translate our graph to. Okay, so now we're going to look at a couple other transformations. We can have some reflections. So if I have a negative f of x, right, so my negative is out front of the parentheses, I'm going to be reflecting over the x-axis. If I have a negative inside my parentheses, I'm going to be reflecting across the y-axis. Okay, so it's kind of important to keep in mind the differences between inside the parentheses and outside the parentheses. Now we're going to look at our stretches and shrinks. So our vertical stretches and shrinks are just like they were back in chapter 1. And think of it as if I'm standing there and somebody stretches me, I get taller and skinnier. And if somebody shrinks me, I get kind of shorter and fatter. So again, vertical is going to be outside the parentheses. Horizontal, inside the parentheses. Just like with our translations as well. Anything horizontal will be inside my parentheses, and anything vertical will be outside the parentheses. Okay? So again, I can look at this. And just look at these pictures and see kind of what we're looking at, right? They're very similar. So, and we always discuss how they get close towards the axis or away from the axis, okay? So check those pictures out, make sure you've got them. So now we're going to describe the transformation, and here's my parent function, quadratic, right? F of x equals x squared, and now I'm going to do some stuff to it. I'm going to do these transformations. So here I see I have a negative, so I know I'm going to have to reflect it. I also have a fraction, so let's see what that makes it look like. Okay. So here's my reflection. Since I started in this black graph, this is my parent f, and I get to g. So I reflect it, and I see that I have a 1/2. This is a vertical shrink, right? And remember, vertical shrink I know because it's less than 1, so I know it's going to get a little shorter and fatter. It's going to get closer to the x-axis by a factor of 1/2. So now let's look at g of x. There's a couple of things being done with g of x. I see something, a number inside the parentheses, so I know it's going to be a horizontal stretch or shrink. But then I also see this number out here. This is outside my parentheses, and this is going to be my vertical translation. So let's look at this. So here's just kind of my general form. So my graph is this horizontal shrink by a factor of 1/2. And I know that it's a shrink because it's inside the parentheses, so I have to make it the reciprocal, right? So it's a shrink by a factor of 1/2, and then I shift the whole thing up 1. This will get the horizontal stretching and shrinking will get easier the more we do it. When we're dealing with vertical, right, so our up and down, I don't have to change anything. I can just use the values as they're given to me. But when I'm dealing with horizontal values, I need to use the reciprocal to determine my factor that I'm stretching or shrinking by. Okay, so try a couple of these. Definitely try the ones that have more than one thing going on. See if you can follow along with those. Okay, so now we're going to look at absolute vertex form. We're going to kind of live here for a long time. So if I have this a value, right, this is a reflection if it's a negative and or a vertical stretch or shrink. I have an h value. This h, remember, was our horizontal translation, so left and right, and k was my vertical translation, up or down. And always x minus h, x minus h. I'm going to say it over and over and over again. So let the graph of g be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of x squared. So now I have to write a rule and identify the vertex. When we're dealing with quadratics, we often want to find the vertex. That's just the place where it changes direction. Okay, so I'm going to start with my f of x, and we're going to see what happens. Okay, so I have a reflection. I have a vertical stretch by a factor of 2, which gives me an a value of -2. Right, the negative will reflect it. The stretch tells me the number there. Then I also have a translation 3 units down, which gives me a k of -3. Now I can write my function. So here's my just vertex form, and I can now substitute my a and my k. Since I don't have an h, I can just leave that as 0 and kind of simplify my equation there. Okay, so my transformation leads me to a -2x squared minus 3. So the vertex is always going to be h comma k, which makes things a little bit easier, and that's why we use vertex form. So my h here, I didn't have an h, was 0, so that is the x value of my vertex. My k, since I moved down 3, is a -3. So that's my vertex. So that's going to help us a lot later on. There's another method we can use to do this. It does the same thing, only just a little bit different. Okay, so we're going to do the transformations one at a time. So first I write my function that represents the reflection and the vertical stretch. So I know that I multiply the output times a -2. So I end up with -2x squared. So now I notice that I have that vertical translation of down 3, and I can write it that way. I still am going to end up with the same vertex. For me, this first method is just easier, kind of trying to figure out what all am I doing to it, and then I can write my function from there. Okay, so here's our next example. So let the graph of g be a translation 3 units right and 2 units up, followed by a reflection in the y-axis of this graph. So you'll notice here I'm not actually starting with my parent function, I'm starting with another function. So now I have to write a rule. Okay, so I'm going to go ahead and write my function that represents my translation of f, right? Because I translated 3 units to the right and 2 units up. Okay, so here's kind of what I'm looking at. So left and right is inside my parentheses, up and down is outside. So here's what it would look like for 3 units right and 2 units up. So I subtract 3 from the input and add 2 to the output. Okay, so now I can just kind of simplify a little bit. So everywhere in my original equation where I had an x, I go ahead and I substitute this in. I substitute my x minus 3 in, and then at the end I add that plus 2. Okay, then I go ahead and multiply these out and simplify. So now I have to take that same function and figure out how I can reflect it So I go ahead and I write my generic equation for a reflection. And then everywhere in here where I see an x, I plug in a negative x, which gives me x squared plus 11x plus 26. And that's as simple as I can get that. So first I always want to look at things in little steps and see what I can come up with. So here's our modeling, right? And we always want to apply these to kind of some real world situations and look at what they look like with word problems. So the height in feet of water spraying from a fire hose can be modeled by h of x equals negative 0.3x squared plus x plus 25, where x is the horizontal distance in feet from the fire truck. The crew raises the ladder so that the water hits the ground 10 feet further from the fire truck. Write a function that models the new path of the water. So here's kind of what we do. And we don't always have to follow all of these steps, right? So we have to just kind of figure out. And I know I'm going 10 feet farther. So I would always kind of, draw myself a picture, right? So if this is what I'm looking at, here's kind of my fire truck. And here's the water spraying. Okay, so I know that I raise this up some so that it hits 10 feet further, plus 10 feet. Okay, so I know that I'm moving 10 more feet to the right. Okay, so I'm also going to graph my original function, and h of 50 is equal to 0. So that tells me that the water originally hits the ground 50 feet from the fire truck. So I can use this. I can use my graphing calculator, or I can use Desmos. Let's look what it looks like in Desmos. So when I graph this in Desmos, here's what I get. This is just that original equation. So I can see here, right, that I start at 25 feet. That's how high it is to start. And it does land 50 feet after it leaves the truck. So what I also notice is on my graph, when my h is 60, is negative 23, right? So I know that this needs to be 60 because I need it to land further away. So down here I can see that at 60 it's going to be at a negative 23. So I can know that if I shift the entire graph up by 23 units, that will help me, that'll move the water further away. Okay, so that's what I go ahead and I do. I go ahead and add 23 to the output. Since this is a vertical translation, right, I'm shifting the whole thing up. So then I can just substitute that in and simplify. So the only thing that really changed is this last constant value in my graph. So now I can go ahead and graph this new one and just double check. Let's go ahead and do that. Let me copy this and paste it. So there's my exact equation. So when I translate this up 23, there's my new equation that I just came up with, and I see that my graph does cross at 60 feet. So I know I was right. So I can use all of the different points in my graph just to double check where I'm at and kind of see what it looks like. So the next thing we have is just a couple of monitoring progress. Really, I want you to look here at some of these word problems. So look at what happens if I'm trying to get the water 10 feet closer to the fire truck after lowering the ladder. What would I do there? Okay, really look at these word problems and spend some time thinking about them. Because the easier the word problems get for you, the easier the entire section will be. So let's look back at our learning targets. First, we described the transformations of quadratic functions, and then we were able to take the different transformations and write those transformations into my functions. So now that we've worked through both of these learning targets, go ahead and work on this homework for this section.